James Webb results have surpassed all our expectations. Made up of a 6.5-meter gold-plated mirror, a sunshield that is the size of a tennis court, and an array of complex instruments that are cooled to temperatures only a few degrees above absolute zero, the Supreme Space Telescope observes the heavens in infrared radiation, revealing details of the universe just after its Big Bang birth, 13.8 billion years ago, and images of stars being born in dust clouds. Notably, in addition to collecting the faint light coming from the depths of the universe and probing the recesses of space-time, Webb's infrared eyes also turn out to be ideal for studying strange and bizarre worlds. And in a landmark observation, James Webb has focused on Proxima b, capturing the clearest image of our closest known exoplanet neighbor seen in history. Interestingly, what James Webb revealed is so much richer than anyone had hoped. Join us as we dig deep into what the James Webb Telescope just revealed. Mark it down. As of January 2024, we've passed a remarkable milestone in discovering the universe. For innumerable millennia, humans and our ancestors looked up at the sky, wondering at the seemingly limitless points of light glittering in the heavens. While many intuited that they might be similar to our sun, except located a tremendous distance away, nobody knew whether our solar system was something special. Did the other stars in the universe have planets orbiting them? If so, what percent of them had planets? How many did they have? And were the planets like ours, or were they vastly different? Just 30 years ago, humanity was beginning to uncover the answers, as we started to discover planets in orbit around stars other than our own. At last, through a combination of multiple different methods, the radial velocity method, timing measurements, the transit method, and gravitational microlensing, we are now well into a new era of astronomy, where distant planets called exoplanets are being detected at a fast clip. At last count, there have been 5,257 confirmed discoveries of exoplanets and another 10,000 candidates awaiting confirmation. These exoplanets are truly amazing, each different, each with its own composition and history. There are no two worlds exactly alike, even when astronomers refer to Earth-like or Neptune-like planets. They mean worlds with masses and radii similar to Earth or Neptune, not duplicates of Earth or Neptune. Enormous variability ensues as planets form, which dictates their chemical composition, geological activity, and atmospheres. So, when discoveries point to worlds with chemicals related, even if superficially, to life, we pay attention. As is often the case, these discoveries have been tremendous and have answered some of our deepest questions about the cosmos. Nevertheless, even deeper ones now remain. Here's also where James Webb enters. One of the main uses of the James Webb Space Telescope will be to study the atmospheres of exoplanets, to search for the building blocks of life elsewhere in the universe. But Webb is an infrared telescope. How is this good for studying exoplanets? Frankly, one method Webb will use for studying exoplanets is the transit method, which means it will look for dimming of the light from a star as its planet passes between us and the star. Collaboration with ground-based telescopes can help us measure the mass of the planets via the radial velocity technique, that is, measuring the stellar wobble produced by the gravitational tug of a planet. And then Webb will do spectroscopy of the planet's atmosphere. Webb will also carry coronagraphs to enable direct imaging of exoplanets near bright stars. The image of an exoplanet would just be a spot, not a grand panorama, but by studying that spot, we can learn a great deal about it. That includes its color, differences between winter and summer, vegetation, rotation, weather. How is this done? The answer again is spectroscopy. Spectroscopy is simply the science of measuring the intensity of light at different wavelengths. The graphical representations of these measurements are called spectra, and they are the key to unlocking the composition of exoplanet atmospheres. When a planet passes in front of a star, the starlight passes through the planet's atmosphere. If, for example, the planet has sodium in its atmosphere, the spectrum of the star, added to that of the planet, will have what we call an absorption line in the place in the spectra where we'd expect to see sodium. This is because different elements and molecules absorb light at characteristic energies, and this is how we know where in a spectrum we might expect to see the signature of sodium or methane or water if it is present. Why is an infrared telescope key to characterizing the atmospheres of these exoplanets? The benefit of making infrared observations is that it is at infrared wavelengths that molecules in the atmospheres of exoplanets have the largest number of spectral features. The ultimate goal, of course, is to find a planet with a similar atmosphere to that of Earth. And in great effort to hunting the Earth 2.0, James Webb has turned its razor-sharp eyes on Proxima Centauri b. A mysterious planet has piqued the interest of scientists and space enthusiasts alike. At only 4 light-years away, Proxima Centauri b is our closest known exoplanet neighbor. Proxima b is a super-Earth exoplanet that orbits a M-type star. Its mass is 1.27 Earths. It takes 11.2 days to complete one orbit of its star and is 0.085 astronomical units from its star. In the habitable zone of its star, Proxima Centauri, Proxima b encounters bouts of extreme ultraviolet radiation hundreds of times greater than Earth does from the Sun. That radiation generates enough energy to strip away not just the lightest molecules, hydrogen, but also, over time, heavier elements such as oxygen and nitrogen. Just because Proxima b's orbit is in the habitable zone, which is the distance from its host star where liquid water could pool on a planet's surface, doesn't mean it's habitable. It doesn't take into account, for example, whether water actually exists on the planet or whether an atmosphere could survive at that orbit. Atmospheres are also essential for life as we know it. Having the right atmosphere allows for climate regulation, the maintenance of a water-friendly surface pressure, shielding from hazardous space weather, and the housing of life's chemical building blocks. Notably, Proxima b is not the only exoplanet that caught James Webb's eyes. Several hundred are relatively close to Earth, and these are now ripe for study with the Webb telescope. WASP 107b and its quartz clouds and the rogue worlds of the Orion Nebula have already been scrutinized, along with a host of other exoplanets. As a result, dozens of planet-sized objects have been discovered in the Orion Nebula via observations that could herald the existence of a new astronomical category. The free-floating entities, which have been named Jupiter Mass Binary Objects, or JUMBOs, appear in spectacular images taken by the James Webb Space Telescope. The objects are too small to be stars, but also defy the conventional definition of a planet, because they are not in orbit around a parent star. The discovery also appears to confound existing theories of star and planetary formation, which suggest it should not be possible to form Jupiter-sized objects through the process that gives rise to stars inside the clouds of dust and gas found in a nebula. Professor Mark McCausrian, a senior advisor for science and exploration at the European Space Agency, said the observations were inspired after data from ground-based telescopes hinted at the existence of the mysterious class of object. We were looking for these very small objects, and we find them. We find them down as small as 1 Jupiter mass, even half a Jupiter mass, floating freely, not attached to a star. Physics says you can't even make objects that small. We wanted to see, can we break physics? And I think we have, which is good. The large, hot, gassy objects appear to be planet-like in their composition, with analysis revealing steam and methane in their atmospheres, but they are not technically planets. The team settled on the name Jupiter Mass Binary Objects because, out of the hundreds of planet-like objects identified, dozens came in pairs. The jumbos are about 1 million years old, babies in astronomical terms, and have infernal surface temperatures of roughly 1,000 degrees Celsius. Without a host star, though, They will rapidly cool and will briefly feature temperatures in the range of habitability before becoming incredibly cold. However, as gas giants, their surfaces would not harbor liquid water even during their brief temperate window, meaning they are not likely to be strong contenders for hosting alien life. The observations focus on the Orion Nebula, which can be seen with the naked eye as the fuzzy middle star in the sword of the Orion constellation. At 1344 light-years away, it is the closest region of massive star formation to Earth, and in the latest images it appears as a celestial masterpiece, with roiling clouds of dust and gas, explosions and starbeams. Stars form when the dust and gas clouds in a nebula cool, progressively fragment and eventually collapse under their own gravity. The smallest stars are about 80 Jupiter masses, below which the core is not dense enough to fuse hydrogen, but smaller objects can coalesce through the same process, including dimly glowing brown dwarfs, sometimes called failed stars, and below about 13 Jupiter masses, planetary mass objects. But theoretical predictions suggest that the lower boundary for an object forming through a star-like gravitational collapse is about 3 to 7 Jupiter masses. Smaller free-ranging objects have occasionally been sighted, but it was unclear whether they had formed in situ or had been ejected from a planetary disk around another star. The latest observations are more challenging to explain because, out of the hundreds of roughly Jupiter-sized objects found, dozens are in binary pairs. How can you throw two things out of a star's orbit in a chaotic interaction and get them to stick back together again? We just don't know. Even Professor Matthew Bate, the head of astrophysics at the University of Exeter, also has to accept that he doesn't know how to explain the large numbers of objects they've seen. It seems we're missing something in all of the theories we've got so far. It seems that there's a mechanism that's forming these objects that we haven't thought of yet. It's pretty rare that this kind of discovery is made. In the last decade, a lot of us thought we understood star formation pretty well, so this is really a very, very surprising result, and we're going to learn a lot from it. Professor Anthony Whitworth, an astrophysicist at Cardiff University, also agreed with this opinion. He described the observations as an amazing result. The binary objects could have formed within a disk and then been kicked out as a pair, he speculated. This would require interactions with other stars in the dense Orion star field. All possible, in principle. Lots to ponder. However, note that the more we learn about other worlds and planetary systems out in our galaxy, the more remarkable our planet becomes, indeed. Because either way, the main motivation of those discoveries is to figure out how rare or common our planet is. If there are lots of Earth-like planets, not just with similar size and composition, but also located at the so-called habitable zone of the star, where water, if present on the planet's surface, would be liquid, then the odds become higher that such worlds could harbor some kind of life. As Elizabeth Newton at Dartmouth College reported a few years back while reflecting on her discovery of a young exoplanet orbiting a relatively young star, one of the overall goals of astronomy is understanding the big picture of how we got here, how solar systems and galaxies take shape, and why. By finding solar systems that are different from our own, especially young ones, we can hope to learn why Earth and our own solar system evolved in the ways that they did. So, it all boils down to one of the most exciting questions we can ask in science. The one kids from ages 5 to 90 ask across all cultures on our planet. Are we alone in the universe? Studying other worlds, their history, location, and properties allows us to figure out our own history and how exceptional, or not, it is. We live in this very special time when we can actually begin to answer this question, and it all points to our planet being a rare gem in a universe that is very hostile to life. We are still far from knowing whether other worlds harbor life of any kind. Clearly, given that there are so many worlds out there, trillions in our galaxy alone, and that the laws of physics and chemistry are the same across the universe. This we do know with confidence. The expectation from a large fraction of scientists is, yes, there should be other worlds with life. Otherwise, as Jodie Foster's character in the movie Contact, based on Carl Sagan's homonymous novel, said, "It seems like an awful waste of space." But life is not so simple as large numbers. There is a disconnect between the way physical scientists and biologists think about this question. Of course, there are exceptions in both groups. Biologists tend to be more careful with such extrapolations, knowing only too well that life is enormously complex. There are many truly mind-boggling steps to go from non-life to the first living creatures, and then on to complex unicellular life and multicellular creatures. What's more, life doesn't have a plan to get more complex over time. Life cares about reproducing efficiently. If species are well adapted, mutations won't do much. Ultimately, the question of how life did emerge on Earth remains very much open. What we do know now, and this is extremely important, is that the life history of a planet, the details of how it evolved from its atmosphere to cosmic impacts and seismic activity, is imprinted on its creatures, and vice versa. Life changes its host planet in dramatic ways. There is a two-way relationship between a planet's history and the kind of life it supports. The planet provides the basic support for life to be possible, and life acts back on the planet and changes it. Earth now is a different planet from 3 billion years ago, when it only had single-celled organisms. Their action changed the planet by dramatically increasing the oxygen levels in the atmosphere. Without that, we wouldn't be here. We can also see this with our own destructive activities and how they are imprinted on Earth. Human presence has permanently scarred Earth. Dominant species can change their world, either knowingly or unknowingly. We are living the reality of this fact. Yet, most of us are choosing not to pay attention or change our ways. Alienated from nature, we seem to have forgotten how much our survival depends on it. Bad water plus bad air equals sick life. That's the equation everyone should know. Call it the survival equation. Maybe what we are learning about our planet and its distant cousins will inspire us to rethink how we relate to our world and the creatures we share it with. After all, based on overwhelming power, we expect to unlock more and more distant world. It will be more exciting if our premier telescope focus on top 8 of the strangest exoplanets in the universe. HD 209458b, Osiris. This planet boasts a number of first discoveries. Scientists have found that it is the only planet currently found outside of the solar system to have detectable oxygen and carbon in its atmosphere. Its parent star is 150 light-years from Earth in the Pegasus constellation. Named after the Egyptian god, who lost part of his body, Osiris revolves around its sun, a mere 4 million miles away. The scorched planet is evaporating at such a fast rate that scientists have begun to create a new classification of exoplanets called Chthonian planets. This nomenclature comes from the infernal Greek deities and H.P. Lovecraft's subsequent usage for his space monsters. It is most likely a dead core of a completely evaporated gas planet. Kepler 16b, Tatooine. Astronomers' research once posited about the possibility of a circumbinary planet, that is, a planet that circles around 2 stars. In an homage to Luke Skywalker's home planet in Star Wars, Kepler 16b is nicknamed Tatooine. Whereas Skywalker's homeworld was habitable, this planet is cold, gaseous, and most likely cannot harbor life. It is 200 light-years away from Earth. The discovery of a circumbinary planet was hinted at and then confirmed with the observation of brightness of the dual star system being dimmed by a planet's transit in front of it. While being in the habitable zone is ruled out for this planet, Kepler's principal investigator William Barucki, on the importance of this discovery, stated, "This discovery confirms a new class of planetary systems that could harbor life. Given that most stars in our galaxy are part of a binary system, this means the opportunities for life are much broader than if planets form only around single stars. This milestone discovery confirms a theory that scientists have had for decades, but could not prove until now. Kepler 22b. New Earth. One of the most promising and early findings from Kepler is the Kepler 22b. 600 light-years away from Earth, it's twice the size of Earth and should have temperatures around 72 degrees Fahrenheit. This planet is considered a super-Earth and is within the habitable zone of its star. Its star is within the Lyra and Cygnus constellations and shines 25% less bright than our Sun. Scientists think that the planet may have a rocky core and be covered in an ocean like Neptune, but life on the planet isn't out of the question yet. Kepler Deputy Science Chief stated that it's not beyond the realm of possibility that life could exist in such an ocean. PSR B1620 6b Methuselah. One of the oldest planets in the known universe so far, Methuselah is 2.5 times the mass of Jupiter. It's also another planet that orbits two stars. At 12.7 billion years ago, this exoplanet tops the aging scales. Interestingly enough, the two stars that it orbits are both burnt-out dead stars. It is 12,400 light-years away in the constellation of Scorpius. At first, scientists didn't know whether to classify it as a brown dwarf or a planet. Since it was created some 1 billion years after the Big Bang, astronomers have concluded that planets are not a rare phenomenon and the early universe was probably teeming with them everywhere. TRES 2b Coal Black. Found during the transatlantic exoplanet survey, TRES 2b is one of the darkest planets we've ever been able to see. Similarly sized to Jupiter, this coal-black planet is less reflective than black acrylic paint. Jupiter, on the other hand, reflects more than a third of the sunlight that reaches it. TRES 2b is also burning up as it orbits its star at only 3 million miles. It's not clear what makes the planet so dark. There are hues of red that emit a faint glow. The darkened planet is 750 light-years away in the Draco constellation. Kepler 452b, Earth's cousin. A planet that's more equally matched to Earth floats along some 500 light-years away from our planet. It's no larger than 10% more of Earth's size. It encircles a red dwarf star with a 130-day orbit. A smaller-sized planet is more likely to harbor and support life, especially inside the habitable zone. Inhabitants on this planet would feel about twice as heavy as they did on Earth. The planet is a lot older than our Sun, as well as it clocks in at about 6 billion years old. There's no confirmation whether or not the planet is rocky or gaseous. GJ504b, pure pink. NASA scientists discovered one of the youngest and most interesting planets in GJ504b. Only 57 light-years away from Earth, the exoplanet is thought to be only 100 to 200 million years old. The insights into this planet are giving astronomers a first-hand look into planet development. According to infrared cameras, it's a deep shade of pink. It also has fewer clouds than the majority of observed gas giants. Michael McElwain, who was part of the discovery team, stated that, "If we could travel to this giant planet, we would see a world still glowing from the heat of its formation with a color reminiscent of a dark cherry blossom, a dull magenta." According to current models, gas giants usually form within a certain range from their host star, GJ504. The pink wonder goes well beyond the established range. 55. Cancri A. Hellfire Earth. Originally dubbed the Diamond Planet, this steaming hot rocky planet orbits its sun in 14 days. It has a temperature of 4,900 degrees Fahrenheit. Scientists who first discovered it suggested that it was composed entirely of diamonds and graphite. While this interpretation has gone out of favor, it remains an interesting planet because of its density and proximity to its host star. The planet is 40 light-years away. The planet is also thought to have lava flows and at twice the size of Earth. Renyu Hu of the Jet Propulsion Laboratory stated that if there is lava on this planet, it would need to cover the entire surface. But the lava would be hidden from our view by the thick atmosphere. While it's still up to debate, The potentially carbon-rich planet with such high temperatures and pressure could hold a large amount of diamond in its interior. That's all the information that we have for you today. And don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.